In this section, just like in the last section, some of the homework is going to ask you to construct a polynomial that satisfies certain conditions. So this is going to be partly review, but we've got a little bit more information now, because in the last section we hadn't yet learned the conjugate pairs theorem. Okay. So here we're asked to find a polynomial of lowest possible degree. So don't throw in factors that aren't necessary if they have x's in them, with integer coefficients and zeros of 2 plus I and 1/2, but where I'm told that 1/2 has a multiplicity of 2. And then we're told to give it in descending order, which means we're going to have to multiply it out. So I'm going to start by finding it in factored form. So if I have a 0 of 2 plus I, then I know that, I'm going to just list my zeros here. I've got 2 plus I, I'm going to have 2 minus I as well, because integers are real numbers, and if I have real coefficients, my non-real zeros come in conjugate pairs. Okay. Then we're also supposed to have 1/2, but 1/2 is supposed to have multiplicity 2. So each of these zeros has a corresponding factor. The factor corresponding to 1/2 we're going to have twice. So in factored form, I would have x minus 2 plus I times x minus 2 minus I, and then x minus 1/2 would be the factor corresponding to 1/2 being a 0, but I've got to have that twice. Now, before I go and multiply this out, I'm going to recall that we were asked to have integer coefficients. If I multiply this out now with fractions in it, I'm going to get fractional coefficients. So what I need to do is clear those denominators. So each of these factors of x minus 1/2, I'm going to multiply by a constant factor of 2. That way I won't have any fractions in my factors, so I won't have any factors when I multiply this out. Now if I distribute that 2, each of these factors becomes 2x minus 1. You'll notice if I set that factor equal to 0, I still get 1/2. I've just been able to write a factor that's equal to 0 at 1/2 that doesn't have any fractions in it. All right, now here I'm going to just distribute my negative. So this becomes x minus 2 minus I, and this becomes x minus 2 plus I. And now I just need to multiply all of this out. These two are just binomials, so I can FOIL this. That's going to give me 4x squared minus 2x minus another 2x is minus 4x, and then plus 1. These two I'm going to multiply out just using long multiplication. And I definitely want to pair those up, because I know if I multiply the factors that correspond to my conjugate pairs here, I should get something that just has real numbers. All of the imaginary stuff should cancel out. So x minus 2 minus I times x minus 2 plus I. I'm just going to write that in this vertical format over here. So now I'm going to distribute the I to each of these factors. So I'll have negative I squared minus 2I plus IX. Now let's distribute the negative 2. That's going to give me a plus 2I plus 4. Now I'm putting that in the same column as the I squareds, because remember, I squared is actually just a real number. Okay. And then negative 2x. And now we'll distribute the x. So I'm going to get negative IX, negative 2x, and x squared. So we'll have x squared minus 4x. The i's times x cancel. The i's cancel. Negative I squared, that's the opposite of negative 1, so that's just a plus 1. 4 plus 1 would give me 5. So I can write these two as being x squared minus 4x plus 5. And now I just need to multiply this out. Okay, so let me clear some space. We're going to multiply x squared minus 4x plus 5 times 4x squared minus 4x plus 1. And then I'm just going to distribute my 1 to each of these. So that's 5, negative 4x, x squared. Distributing the negative 4x, I'll get negative 20x plus 16x squared minus 4x cubed. And distributing the 4x squared, I'll get 20x squared minus 16x cubed, and then 4x to the fourth. So that gives me 4x to the fourth minus 20x cubed. Let's see, 20, 36, 37x squared minus 24x plus 5. Now, that's not the only answer I could have. I can't have anything of higher degree. We were supposed to find the lowest possible degree. I had to have a total of 4 factors because I had to have the x minus 1/2 twice, and I know that my non-real 0 of 2 plus I came with its conjugate pair 2 minus I. So I had to have 4 factors. Okay. The only extra stuff I could throw in would be a constant factor. So I could multiply this by any integer and that would preserve the fact that I had integer coefficients. Okay, excellent. So I'm going to have you try one. This is number 45 from the homework. So again, it is part of the assigned homework, so you're getting a jump start on the homework by doing this. I want you to find the polynomial of lowest possible degree with integer coefficients. So same setup here. I'm just going to change the zeros. You're going to have 7 minus 4i is a 0, and 0 is a 0, and it's going to have multiplicity 4. Okay, so same basic directions, except I'm changing what the zeros are. So the zeros are 7 minus 4i, and 0 with a multiplicity of 4. See if you can find that, and then tune back in, and we'll go over that together. So I've just summarized the information up here. I know that 7 minus 4i has to be a 0, and 0 is a 0 with multiplicity 4. Since I'm looking for integer coefficients, and integers are just real numbers, I know that this is going to come with its conjugate pair. So 7 plus 4i also has to be a 0. Now, that's going to be a complete list of all of my zeros, because if I added any other zeros, I'd be throwing in additional factors, and then I wouldn't be getting the lowest possible degree, which was part of this problem. Okay. So each of these zeros now comes with a factor. So we'll have x minus 7 minus 4i times x minus 7 plus 4i. And then the factor that corresponds to 0 would just be x minus 0. But notice x minus 0 is just x, but we have to have 4 of those. So we're going to have to multiply by an x to the fourth in order to get 0 with multiplicity 4. Now here I'm just going to distribute my negatives. This becomes x minus 7 plus 4i times x minus 7 minus 4i times x to the fourth. I'm going to multiply out those first 2 factors using long multiplication, and then we'll just multiply through by x to the fourth. So if I do x minus 7 plus 4i times x minus 7 minus 4i, let's distribute that minus 4i. So that's going to give me negative 16i squared, positive 28i, negative 4ix. Let's distribute the negative 7. It's going to give me negative 28i, positive 49, and I'm lining that up with the I squared because I squared is a real number, and negative 7x. Distributing the x, we'll get positive 4ix, minus 7x, and an x squared. All right, so we've got x squared minus 14x. The imaginary x's cancel. The imaginary numbers cancel. Negative 16i squared is positive 16, because that's just negative 16 times negative 1. Adding that to 49, I'm going to get 6 plus 65. Okay, so these first 2 factors are just x squared minus 14x plus 65. We've then got to multiply that by x to the fourth. So we would have x to the sixth minus 14x to the fifth plus 65x to the fourth. There's our polynomial multiplied out in descending order. Now, if you have any integer multiple of that, that would also be a correct answer. You could multiply by 2, you could multiply by -5. What you can't have is anything of higher degree, so you can't have any additional factors that have an x in them. One quick note I forgot to mention. There is one topic in this section of your text that I'm not lecturing on in these videos, and I didn't assign any homework that deals with that topic. And that's finding upper and lower bounds for your real zeros. Okay. Now an upper bound would just be a number so that you know that nothing bigger than that is a real zero. And a lower bound is a number so that you know that nothing smaller than that is a real zero. So for example, if I knew that all of my real zeros were somewhere between -2 and +3, -2 would be a lower bound and 3 would be an upper bound. Now, it can be useful to know that when you've got a long list of possible rational zeros, because that can tell you that you don't need to bother checking some of the bigger numbers. However, there's so much going on in this section. I really want to focus on what we've discussed together. That is stuff that you really should know. You are more than welcome, if you want to read up on the upper and lower bounds, and to use that. It would basically allow you to strategize to say, I'm not going to bother checking these ones. But I don't think it's necessary to know that. So you're not responsible for it, but I did want to point out that it is in the book, and some of you might find it's worth learning because it can help you eliminate some of the error in the trial and error when you're trying your rational zeros.